This ability to break things down is a talent, if you will, that can be harnessed to help us deal with some of our problems like pollution. These rotters, they can break down anything that's natural. That's what they've evolved to do, anything that's hydrocarbon-based. So that includes stuff like oil spills, pollutant problems. That's kind of the truth of it.
I was a part of this experiment.
There were 4 piles saturated with diesel and other petroleum waste. One was a control pile. One pile was treated with enzymes. One pile treated with bacteria. And our pile we inoculated with mushroom spores. The fungi absorbs the oil. So the fungi is producing enzymes, peroxidases, that break carbon-hydrogen bonds. These are the same bonds that hold hydrocarbons together. So the fungi becomes saturated with the oil, and then when we return 6 weeks later, all the tarps were removed, all the other piles were dead, dark, and stinky. We came back to our pile, it was covered with hundreds of pounds of oyster mushrooms. Some of these mushrooms were very happy mushrooms. They were very large, showing how much nutrition that they could have obtained. But something else happened, which was an epiphany in my life. They sporulated. The spores attract insects. Birds then came bringing in seeds, and our pile became an oasis of life.
Mushrooms are the fruiting bodies of fungi. So the mushroom is like the apple. The bulk of the organism is growing underground, and it's composed of these long threads. And these threads grow one cell at a time, and then they branch and rebranch, growing in every direction they can, even 3-dimensionally. And that mass of threads is called a mycelium.
A stick falls onto the ground, I pull it up, and there's mycelium. It is virtually everywhere.
A mycelium has more networks than our brain has neural pathways, and works in much the same way with electrolytes, electrical pulses. They're the most common species on Earth. They're everywhere.
Just to give you an idea of how much fungi are in the forest, as you're walking through, it's about 300 miles of fungi.
Under every footstep that you take, and that's all over the world.
And they form these massive links. It's like a big web, just growing through the forest.
Mycelium that can grow out even just this big can have trillions, literally trillions of end branchings. Almost everyone knows about the computer internet. The mycelium shares the same network design.
Trees are communicating using the mycelium as pathways. They're connecting one tree to another. They're using the mycelium too to feed one another. In other words, one tree can swap nutrients with another tree using mycelium as the passageway.
So we often think of kin recognition as an animal behavior. Humans, we love our babies. We know it's our baby and we're going to look after that baby. Well, we never thought that plants could do that, but we're finding in our research that plants can recognize their own kin. So these mother trees recognize their kin through their mycorrhizal networks. The mother tree and the baby seedlings are sending signals, talking to each other. When they're connected together and carbon is moving between plants, the trees are supporting the weaker ones. If she knows that there's pests around and that she's under danger, she will increase her competitive environment towards her own babies so that they regenerate further away. It's a magical thing. And this could not happen without the fungi.